Hey, welcome back to another training video. We are once again in Conversational Cam Pro, focusing on a new toolpath. This one is another spiral toolpath. It is the Spiral Twist. This allows us to create some really custom aspects when it comes to spiraling. So we're going to be answering two specific questions. What does this process actually do? What does it look like? And what's the finished result of the part after we're done with this custom spiral twist process? The other thing is making sure we're answering how do we program it? How do we control it in different ways? And so this is just going to be the getting started process. And so we'll be able to lay this out at least generally, but we can go much further in other videos. We'll assist this with visual aids using our 2D drawings in Aspire, as well as the cutting action taking place on the machine. So we're going to get started by going over to the Aspire software. And just like other spindles that we've done for the spiraling process, we have the design of the square on the end of our blank, and the center section is where it's going to be turned round, and we're going to apply the spiraling toolpath between these two cuts. So far, this has already been programmed and cut to turn this round using a surfacing cutter all the way to the end, from beginning to end in that way. And then a classic spiral cutter is being used to turn this tool profile here and here around the circumference of the part. And again, if you haven't seen how to do those programming aspects, go check out those videos. Highly recommend it. So the spiraling toolpath, the difference between a spiral twist versus, let's say, a rope twist and a barley twist is that when we were doing a rope and barley twist, the Secant Pro software would automatically calculate the pitch. Okay, and the pitch is how far the cutter travels down the material per rotation of a twist. So, for example, if I wanted to take this classic spiral and perform a twist with this classic spiral down the length, it would plunge here and then travel just down the blank as it rotated until it got to the ending position and then lifted out. So the pitch is how far it travels down the stock per one full rotation of the material. Okay. If we had a single start twist, the software would automatically calculate to shift the cutter over the same width of the cutter that we select. Okay, so for example, the cutter would start here and it would travel this far per one full revolution if it was a single start spiral. If it was a two start spiral, the cutter would actually end up over here. So that's a two start spiral is that pitch, as an example, and so on and so forth. So the way the software works with other like barley twist and rope twist is it takes the diameter of the cutter, it multiplies the number of starts that are in the twist, and that becomes the actual pitch, the distance it travels per rotation. Okay, and that is automated. Okay, we don't have an option to actually not turn that off in the rope and barley twist processes. However, in the spiral twist process, we do. We have the full functionality of customizing what we want our pitch to be, and it can be anywhere. I can make any distance per rotation on our pitch using whatever cutter choice we want to apply. So let's actually show you a design application in which this would take place. Okay, so I have some designs laid out here. So if I wanted to, again, take this classic spiral, if we were to apply this, just pop it on here. And again, this isn't really necessary for programming, but it helps visualize what we're trying to accomplish. Okay, so if I was to take this classic spiral and again have it perform a single start spiral, but I want the pitch to be this distance. Okay, and we can always measure that just so you have an idea. So a horizontal dimension from the center of this cutter to the center of that cutter is 3 1/4 inches. And so that is the pitch that the cutter would have, the distance it travels per rotation as it went down that entire spiral. And you'll notice that it leaves sections between the spiral that are untouched, that are simply just turned round in those areas. And that could be a design. That could be a design that someone wants, is by just controlling the pitch and the number of starts, we can, again, create other unique shapes and designs other than having cutters be back to back to back with our spiral twists. And so if I wanted to program, let's say, this specific design, let's go show you how it's done in Secant Pro. So if we go to Secant Pro here, we're going to select the training project, and we're going to go to our blank that we've been using to manage our toolpaths. We've already turned it around. We've already done the 2 tool profiles. It's been programmed. We're going to be adding the Spiral Twist application where we can customize our pitch. Okay, so if we close that, we go into our Spiral Twist process and answer these questions. So the first thing we get to answer is what cutter we're going to use. And in this scenario, I'm going to use the exact same cutter we did for the tool profiles, and that is the classic spiral cutter. It's a 2-inch diameter classic spiral. Look familiar? Okay, so I'm just matching it to that same cutter that we're already using, so there's nothing special about that, so we can select that tool. And this was already used for tool number 2 in the tool profile toolpaths. I'm just going to match that since it's the exact same cutter for tool number 2 as well. And now we get to choose where does the spiral start and end. So let's go grab those parameters. And these parameters will be the exact same as what we used in the profile parameters when I programmed that earlier. But if we go here to our dimensions and we do a horizontal dimension from the left side, which is X0, to the center of this cutter, okay, that will give us a starting position for that spiral. And from X0 to the center of this cutter here is the ending position for the spiral. So it's going to start at 5 and end at 13 over that length. So let's go put that in here. So if we go 5 at the starting position and 13 at the ending position, we're going to hold a lot of these things default. So for example, the cut depth, we're going to use the profile height, pass depths, feed rates, all those are going to stay the same. We're going to pay attention to the fields that are empty. Okay, so this one is asking how many starts do we want to have on this twist? Well, if we look here, this cutter is actually a single start spiral. It's just starting here and it's rotating down and back as a full rotation over that distance. And it's just repeating that all the way down. So it's leaving this gap as a single start spiral over that distance. And so this will just be a start of 1, or number of starts, just 1. And now here it's asking, what do you want that spiral pitch to be? And we had shown that parameter earlier, but let's go grab it one more time. So a dimension from the center of this cutter to, again, the distance it travels per rotation is the pitch right there. Okay, so where it's going to travel 3.25 inches for our pitch. So if we go in here and put a spiral pitch of 3.25 inches, and we'll leave all this defaulted. And what is the section diameter that this is being turned onto? So this was also the diameter. If we do a dimension here as a vertical dimension from what's already been turned around, the 2.5 inch diameter section is what this spiral twist is being applied to. So 2.5 inches. So we can put 2.5 inches here and that finish and save. So we have successfully programmed the twist factor, again, the single cutter going around. And we could turn that, but I want to just show one additional thing. What if we wanted to apply a different cutter shape in the middle section here where, again, nothing is being applied yet? Okay. So for example, I have another design down here to show exactly that. So this is the, again, exact same twist, except this time what we've done is we've applied this ball cutter, a core box cutter, to follow the twist in those middle sections where the classic spiral was not cutting. And it gives us another design aspect. So let's go program that as well. The first thing we need to do, though, is I need to actually rotate the stock as a separate tool path, because this has ended and started where the classic spiral, again, began. But I don't want my ball cutter to cut in the same location as the classic spiral, right? And because this cutter is one start going over one full rotation over 3.25 inches, I just need it to rotate on the other side of the blank to start my core box cutting. Okay, think of it like this. Think of it that if we had a cross section here that was 2.5 inches, right? And the classic spiral, so that's where the classic spiral would cut as a single start, just wrapping around. And then the core box cutter, I'm just going to copy this. This is going to be on the opposite side. Okay, again, cutting right here, but that's going to be cutting a certain plunge depth as well, giving us that core box shape. And so these two cuts are opposite, on opposite sides of one another when cutting on the blank, but again, spiraling around one another. Okay? So think of it that way. It's pretty much a two-start spiral, but we programmed one separately, and we're going to program the other one separately so that we can select different cutters for those two starts. Because we just barely finished programming the classic spiral, now we need to rotate this entire thing. The entire blank needs to rotate, 180 degrees so that it's in position for the core box cutter to take place. So if we go over here to Secant Pro and manage my toolpaths, this is one toolpath that hasn't been covered yet, but this is really easy to apply. It's under the other category, and we are simply going to set and rotate the A-axis at whatever amount we wish. So we're going to insert that, okay? And let's go take a look at that just so you can see it. So we're going to go to Set A-axis as this toolpath, and we have the option to say, hey, do you want me to set the value at where it is right now? No, we don't need to do that right now. We just simply need to rotate the blank a certain amount. So we're going to say rotate the A-axis to a position. We're going to say an absolute position of 180 degrees. Okay, so halfway, just a half rotation. And then after it's rotated, let's say 180 degrees, let's tell it then to set the value of where it's at to 0. So it doesn't try to rotate back to 0 degrees, but we're just rotating 180 degrees and then zeroing out the A-axis is what's going to happen in the programming code for us. So we can go finish and save, and that now has the twist factor as well as rotating 180 degrees, and we're now ready for the second cutter. So if we go to Manage Toolpaths, and we're going to add the spiraling one more time, one more twist. So we're doing 2 twist factors, one with the classic spiral, one with the core box. We can close that and go into our twist here, and this will be the core box. So if we select our tool, we're going to go into our core box tool. Now, I specifically chose a certain size, and I'll show you why after we select this cutter in just a moment. I chose an 1.5" core box. So let's select that tool, and this is going to be tool number 3, okay, for this process. But let's go see why I chose an 1.5" core box. So if we go back to our drawing here, what I did is this core box is also starting at the same position of that profile cut, except I had it cut deep enough, okay, there, that depth lines up with those flat surfaces. Okay, so this cut depth is the same as, you could say, that cut depth right there in the material. So what I needed to make sure is if this was in the center, that's where the cutter is going to end up in space as it plunges down and then starts cutting. And you can see it's just enough to where it's not going to make contact with my profile cutter that's already turned around the circumference of my part. So that's the reason why I chose an 1.5", because if I go any bigger than this, the cutter actually ended up cutting into the edge of my profiles, which I didn't want. So I wanted to have a cutter small enough that it could fit within here at the starting position, but also give me a nice big radius for the spiral effect. So if we look back here, where is the start and end position of this spiral? Well, it's going to be the exact same of what we did with the classic spiral cutter. It's going to start at 5. It's going to end at 13, okay? Same positions. So 5, 13. Except here, this is where we're going to have a slight difference, is we're not going to use the full height of the cutter as our cut depth. For example, this cutter here, the full height goes from the tip to, again, where the radius ends. That's a lot. It's a 3/4 inch cut depth. Whereas this is not 3/4 inches deep in the material, okay? So we're going to measure that. We're going to grab a dimension here. I'm going to measure a vertical dimension to say from the tip of the cutter to the surface diameters, how far it's going to cut, okay, or cut depth, and that's going to be 0.3125. So if we go back here and say use the profile height as our cut depth, no. I'm going to say no, don't use that, and we're going to put in the cut depth 0.3125. So now we've customized the cut depth. That's the first time we've done that, based on using just a portion of the tool instead of all of the tool to create the shape, okay? And then down here, we can finish with the rest of the same parameters. So how many starts does this core box have? And it's the same as the classic. It's a single start spiral, okay, going around. And so we'll put 1. And the spiral pitch is also the same as what the classic spiral was, okay? 3.25 inches. I could measure that with the core box as well if I want to get the exact same dimension. And you can see it's a weird step, but 3.25, 3.25. So it's the exact same, okay? So we're going to put that in there, 3.25. And the section diameter this is all turned on to is the same diameter section here of 2.5 inches for that core box. So 2.5 inches, and we are done. So now let's generate the G-code. We don't need the Toolpaths, the first two, that's the turning around and the tool profiles. We'll combine the 2 twists and the A-axis rotation into one program. And so let's generate our G-code, and this finishes it off using 2 cutters now. So we have, and tool number 2 is the 2-inch classic spiral, and tool number 3 is that 1.5-inch core box cutter being used to apply that design. So that's all it took, and we can now save our G-code. And under our Toolpaths, we're going to have a spiral twist technique. And here, this is going to be the spiral twist, not drawing file, but this will be the spiral twist G-code. And save. Now let's go to the machine and see how this turns out. Just like other spiral toolpaths, it comes to the starting position and plunges for our first roughing pass and travels down the stock while rotating. Now this is going to take 4 passes for this cutter because it has to plunge deeper than the other tool. But we can see that the pitch, the distance it travels per rotation, is leaving that flat gap left over for the core box cutter. At the end of this first spiraling process, you can see that it lifts up and then rotates that 180 degrees, repositioning it for the next cutter. The core box cutter repeats the exact same process, but because it doesn't have to cut as deep as the classic spiral cutter, this is going to perform in 2 passes instead of 4. The ability to control the pitch in a spiraling toolpath really opens up a lot of versatility when it comes to these types of techniques. All the cutting advantages shown here are automatically implemented into Cam Pro. You should now have a basic understanding of how to do a spiral twist toolpath, so go out and try this yourself. Now these types of videos generate a lot of different questions. I recommend you take advantage of 2 resources to answer your questions. First is head on over to our website at legacywoodworking.com. There you'll find all the different product information, additional cutting demonstrations, and much more. The second resource I recommend doing is actually getting in contact with one of our CNC experts. You can call them at 801-491-0010. They will be happy to answer any of your questions, put on software or cutting demonstrations with the machines, and point you to additional resources, again, to fulfill your needs. Now, if you'd like to just simply watch more videos, I don't blame you. Just click right over there. I think we all know what to do. If you want to be notified of future videos, just click that button down below, and don't hesitate to give us a like if you liked what you saw. As always, thanks for watching, and remember, Legacy solves more woodworking problems and allows you to say yes to more opportunities than any other CNC manufacturer in the industry.